Well, hi, everybody. My name is Simon Nicholson. I'm co-director of the Forum for Climate Engineering Assessment, which is a group out of American University in Washington, D.C. This is the first in a series of webinars that we've set up to look at so-called carbon dioxide removal or negative emissions technologies. I'm joined today by Janos Pasztor, who I'll introduce in a moment, and Katharine Mach from Stanford University. And next to me is my colleague, Wil Burns. The Forum for Climate Engineering Assessment was established some years ago to establish a bridge between the policy and academic conversations about a set of emerging and in some cases imagined technological responses to climate change. In this webinar series, we're going to look at a particular bucket of response options. These are technologies that would remove large amounts of carbon or other greenhouse gases from the atmosphere and hold these gases in storage or put them perhaps to beneficial use. The sorts of questions that we want to ask throughout the webinar series are things like, what are these technologies? What role might they play as part of a portfolio of responses to climate change? What are the risks? How might we manage these technologies in ways that are beneficial? And what might the future hold? In this first webinar in the series, we want to set the stage. So the three guests that we have will join us in answering some big, broad questions about what carbon dioxide removal technologies are, why they're being talked about, and will give us a sense of the current international conversation and some of the risks and opportunities around this technological form. Our three guests are first Katharine Mach from Stanford University, where she's a senior research scientist and director of the Stanford Environment Assessment Facility. Her research is focused on integrative assessment of climate change risks and response options. Second, we have Janos Pasztor from the Carnegie Council. He's a senior fellow and executive director of the Carnegie Climate Geoengineering Governance Initiative, C2G2. Before taking up his current assignment, he was UN Assistant Secretary General for Climate Change in New York under Secretary General Ban Ki-moon. And next to me is my colleague, Dr. Wil Burns, who's co-executive director of the Forum for Climate Engineering Assessment. We had Dr. Oliver Gedden listed as a panelist today. He had a last-minute conflict, but with Janos, we have a very worthy replacement. So we're going to jump straight in with Katharine. So Dr. Mach, we've asked you to come and give us the high-level overview. What are these technologies? Why are they being talked about as part of the climate response conversation?
Great. Thank you so much, Simon, and it's wonderful to talk with all of you today. Simon mentioned the word risk a number of times in introducing the set of conversations we'll have over the next hour and a half, and that's where I'd like to start as well. I think there's increasing recognition that viewing the climate challenge as a challenge in reducing, managing risks is a really helpful entry point. And what I will unfold in introducing what we mean by carbon dioxide removal is the fact that this is also very much relevant in this context of risk. And the backdrop for our risk conversation is a world in which we're already seeing widespread impacts and one in which we have serious risks in the pipeline if we continued with high emissions of heat-trapping gases. So that's theme number one, risk. Theme number two that I'll introduce is the concept of a carbon budget. And the basic idea is that when we put carbon dioxide into the atmosphere, the warming from that gas is nearly permanent. As it drops in concentration slowly in the atmosphere through time, the oceans become less able to take up heat. And so the basic math here is that if we want to stabilize the climate, we have a finite carbon budget. Once we have exhausted that budget for our emissions of CO2, other long-lived forcers, we need to be at zero emissions to have stabilized the climate. And then when we say, well, there are targets like limiting warming well below 2 degrees Celsius. The carbon budgets for those types of ambitious limits on warming to keep in check the most dangerous impacts of climate change are actually quite small when we consider how much we have already put into the atmosphere. So we're 2/3 of the way through the budget for 2 degrees Celsius warming. We will likely expend that within about 2 decades if we continue at current rates. So it's a rapidly dwindling budget where 2 degrees Celsius is a very big ask for the planet. Okay, so next, how do we grapple with this challenge of risk and the fact that we've got a finite carbon budget and real time pressure in our responses? Back in the day, many decades ago, the real conversation was, do we adapt or do we mitigate? And in some ways, we're in a much more nuanced position now where we know we need to grapple with impacts as they're unfolding in real time at the same time that we seriously respond. And those serious responses require direct reductions of emissions from our land and energy systems, but increasingly there's also recognition that carbon removal, or removing carbon dioxide from the atmosphere, can play a really important role. I'll get at why it matters in a second, but I'll first introduce how to think about several different buckets of approaches for achieving carbon removal from the atmosphere, also called negative emissions. So the first key feature is that you need to get carbon dioxide out of the atmosphere. And the second key feature of these responses is that you need to store it somewhere. The three buckets of responses that I like to think about differ in A, how you get carbon dioxide out of the atmosphere, and then B, where you store it. So on the fully biological side, you can use photosynthesis, the fact that plants draw CO2 out of the atmosphere as they grow, to get CO2 out of the atmosphere. So planting trees or improving the management of land uses biology, photosynthesis, to get CO2 out of the atmosphere and then to keep it bound up in that plant mass through time. There are also approaches that are biological in the capture of CO2 from the atmosphere, so growing bioenergy crops, for example. But the storage in the second category looks different. It's getting the CO2 deep underground into safe storage in geological formations like saline aquifers or depleted oil and gas wells. Bioenergy with carbon capture and storage is a major technology discussed in this biology with some engineering category, and one that I think we'll talk about quite a bit over the next hour and a half. Third category of carbon dioxide removal is engineered in how you get CO2 out of the atmosphere. The capture essentially is chemistry, solvents or sorbents, sometimes with temperature in there as well, but again, getting the CO2 deep underground into storage. Overall, this approach is called direct air capture. In terms of why these approaches for carbon removal are really important, there are a few different ways to think about key features. Number one, as we head towards that endgame energy and land use system in a stabilized climate, we know that the endgame will require net zero emissions. At the same time that there are some sectors or parts of our economy, airline travel or cement and steel manufacture, for example, that are really hard to decarbonize fully. So carbon removal at any one point in time as we head towards that endgame energy system can help balance out these difficult to decarbonize types of emissions. Carbon removal can also give us some flexibility through time, doing a little bit less now, more later, although we'll come back to some of the risks inherent in that kind of betting of an approach. But in thinking about flexibility through time, there can be the potential for overshooting temperature targets or shaving the peak in terms of how much warming is realized. A final reason that carbon removal can be really powerful is that there are lots of co-benefits. Good things that happen when you improve the management of forests, for example, or the jobs that can be created through some of these different technologies. But what we'll describe again and again is that it's really critical to be smart about the use of carbon removal technologies. That's being smart about the risk trade-offs, and also smart about tapping the opportunities and being attendant to the ethical dimensions. In terms of those ethical dimensions, I'll just close with mention of three of them. I think a key one is to keep in mind that if we're talking vast scale, long-term displacement of responsibility for addressing this challenge, assuming that we'll just start sucking carbon dioxide out of the atmosphere at planetary scale, no problem. There's a can-kicking ethics implied there. We really need to be serious about emissions reductions and carbon removal, not one or the other. In terms of the strategies that rely on the land, bioenergy crops, for example, there's real attention that's needed to how much land are we assuming? What is the water footprint of those types of responses? And then finally, I think a really key feature to be attendant to is what is called the peak and decline scenarios, where we assume that temperature could increase, but then we'll rein it down later on. In terms of emerging science on understanding the implications of a peak in temperature, I guess what I would just emphasize is that has not been something that has really been studied historically. It's starting to be studied now, but we don't really know how to think about the risks of your irreversibilities, whether it's ice sheet loss, increased loss of greenhouse gases from permafrost, or even the degree to which ecosystems could adapt to temperature and then adapt back to cooler temperatures. So I think you'll hear throughout this set of discussions how important carbon removal is, how exciting it is in terms of the near-term opportunities for deployment and research and deployment out there in the real world as well, at the same time that we really need to be smart about incorporating it into our response portfolio.
Thanks, Katharine. So one thing for Katharine and Janos and Wil, and for everybody who's listening, we only have an hour with you today rather than 90 minutes. I apologize. I wish we had more time to talk about. One other thing for everybody who's listening, you've entered the room in listen-only mode, which means that if you want to pose a question to the panelists, you should use the chat box for that question, and we'll find ways to insert questions throughout our hour together today. Just a first question, Katharine, back to you, just so you can help us understand what those three categories are again. Can you just list those three categories one more time that you gave us about how you kind of categorize carbon dioxide removal technologies, and just give us a couple of examples of technologies under each of those heads, just so we understand the universe of technologies that are being talked about?
So I think there are two key features. Number one, how do you get carbon dioxide out of the atmosphere? Number two, how do you store it? And in thinking about those two features interacting, I like to stretch out the space of responses on the spectrum that on one end is totally biological. The capture is biological, the storage is biological, and the other end, it's fully engineered. The capture is engineered, the storage is engineered, and in the middle, you can have capture through biology, but with more engineering in there. So in that first category of the capture is biological, the storage is biological, that ranges from planting trees, changing how we manage forests so that they store more carbon, changing how we manage soils so they store more carbon, or reabsorb some of the carbon that's been lost through agricultural processes over time. In the middle category of biological capture, but more engineered, that can range from what we'll talk about, bioenergy with carbon capture and storage, through to things like building with biomass or biochar into soils. And then on the other end of the spectrum, it's things like enhanced weathering, but most of all discussed in that category is direct air capture, where you're using sorbent solvents to get CO2 out of the atmosphere, but then it's again carbon capture and storage to get the CO2 safely underground.
Thanks, Katharine. And so as I mentioned at the very start, and if you're just joining us, this is a first webinar in a series organized and hosted by the Forum for Climate Engineering Assessment out of American University. As I said right at the front end, we'll be running a series of these webinars. In coming webinars, we'll be looking at each of those different technological pathways that you mentioned, Katharine, and experts will come in to help us evaluate, assess, understand these technologies, and then we'll pull together themes at the end about governance, about assessment towards the end of the series. Janos, thanks for calling in from Europe and for stepping in at the last moment. I wonder if we can turn to you now and you can help us gain a sense of the international conversation as it's developing, particularly in the wake of the fifth assessment report of the Intergovernmental Panel on Climate Change and the Paris Agreement. If you could kind of give us some of this context for the emerging conversation about carbon dioxide removal technologies.
Thank you, Simon, and thank you for inviting me to talk. And I will try to do what you asked me to do. So basically, I'll talk about four things in the next 10 minutes. First, looking at what's happening in some of the intergovernmental processes, like the Intergovernmental Panel on Climate Change, the Biodiversity Convention, the UN Framework Convention on Climate Change. Then what that all means in terms of the carbon budget that Katharine already referred to, and then look at what governance we have in place today in relation to either geoengineering in general or carbon removal specifically, and then a final section of what we need to move forward into the future. So I'll try to do that, and then of course I look forward to some discussion. First of all, the Intergovernmental Panel on Climate Change, the IPCC, already in its previous assessment, the fifth assessment, which was published a few years ago, there is a consideration of both carbon dioxide removal and solar geoengineering. It's not very extensive, perhaps for some people, but it's there. And what is more important is that the scenarios of the IPCC, most of them include some kind of negative emissions technology or carbon removal in order to reach the 2-degree goal, which at that time was the yardstick. We now have a special report of the IPCC that is being prepared as we speak. It will be published in October, which will address the pathways to how one can get to 1.5 degrees and the implications of that as a result of the Paris Agreement decision. It seems from the initial drafts that, again, both types of geoengineering will be considered in that report. And the only question is how far the discussion will take us. And it also appears, although it's still early stages, that the sixth assessment report of the IPCC, which will be available in 2021, will also have sections addressing both carbon removal and solar geoengineering. So at least in terms of the intergovernmental process that brings together the existing science, there is some level of consideration of these issues. Now, in the Paris Agreement, there are essentially four elements of the agreement that I think are very relevant for this discussion. There are, of course, many other parts of the Paris Agreement, but the four for me are, first of all, the temperature goal, that is to keep the temperature rise well below 2 degrees and, if possible, 1.5. So I just use the range 1.5 to 2 degrees. And then the second one is to have, as Katharine already mentioned, reach net zero emissions by sometime in the second part of this century. And that, of course, implies some level of carbon removal technologies. The third element was the national climate plans, or the NDCs as they're referred to, of what every country has decided is able to do in terms of reducing their emissions and also for adaptation. And fourthly, it's the mechanism to ratchet up the ambition every 5 years so that as we go further into time, the ambition level of the national climate plans will be increased. Now, one can ask already now, is Paris successful? We know that the national plans, the NDCs that have been submitted to the Paris Agreement, will not give us the temperature goal that we need. They will give us only about 2.7 to 3.5 degrees if 100% implemented. So we need to do better, and that's the whole idea behind the Paris Agreement. Now, countries will be looking at those plans for the first time in a systematic manner at the end of this year in the Conference of the Parties, at the Talanoa Dialogue, as it is called, to see what they will do about the ambition level of the totality of their emissions. But in reality, it's only in 2020 that we'll begin to see whether the Paris Agreement is working, when the next round of national plans will be brought in. And if they're much increased ambition, then we know we're heading in the right direction. So the Paris Agreement has those four elements, and the package implies the use of some level of carbon dioxide removal. Now, where we're heading is I mean, this was already referred to by Katharine, but most of the models tend to show that it is either impossible or very difficult to stay below the 1.5 to 2 degree range without some level of use of carbon removals. Theoretically, it's still possible to do it without it. There are all kinds of scenarios which also show that if we do much increased mitigation, and if we do this and that, and if we do all that, then we can do it. But in a realistic assessment, in terms of the socio-political and economic considerations, the window for reaching those goals without carbon removal is closing literally by the day. So the likelihood of that there is increasing, that carbon dioxide removal will be used. And we need to also remember that even if we stopped all emissions today, there is already enough carbon in the atmosphere that will stay there for a long time, and it will continue to have a negative impact on the climate. So at some point we have to also remove that, the past pollution. But not getting too much into the discussion of whether or not CDR will be used or to what extent, if countries choose to make use of carbon dioxide removal, then it has to be, those technologies and those processes have to be well governed. And so what do we have in place to govern these technologies? And first of all, we have decisions from the Convention on Biological Diversity dating back 5 and 4 years ago, respectively, that began to essentially provide governance to both solar geoengineering and carbon removal, and those are still in place. Also, the London Convention, the London Protocol of the London Convention has agreed on an amendment to the London Protocol concerning marine geoengineering. So there are some elements that are in place. But in a sense that one of the most important intergovernmental processes is the UNFCCC, the UN Framework Convention on Climate Change, where the discussion of carbon removal has been very little up till now, even though it's there, it's part of the Paris Agreement, but it's there as a almost like a hidden hidden element. And that is true for the formal negotiations, but in the side events where all the observer organizations and the NGOs come, there has been a substantial increase in discussion about those issues in the last few years. Now, what is it that we need? So there are a few elements that I'd like to mention. First, we need to recognize, the leaders, the negotiators, the NGOs, that carbon removal is something that is very likely going to be part of our toolbox, and we have to find ways of dealing with it. And many of these entities that I mentioned are not even willing to talk about it. So we need to talk about, we need to be able to discuss. The second is quite important, although I'm not addressing the private sector in this presentation at all, but we need to continue to work on carbon price and related issues, because that is what will drive the innovation that we need. The third is that within the UNFCCC, the UN Framework Convention on Climate Change, we need really substantially increased consideration of carbon removal. And there are a number of elements there, and I just quickly run through 5 of them. So first, there needs to be a discussion between what is the difference between emission reductions on the one hand and carbon removal on the other. The molecule of carbon is always the same, but the reduction of current emissions versus cleaning up the past through carbon removal is a very different process. And that leads to a very important question of who is responsible for carbon removal. And we need to think of equity considerations there, and also ethical considerations like Katharine mentioned earlier. Then we need to be able to measure what we're talking about. We've heard statements that France is going to be carbon neutral by year X, and so will Norway by year Y. We don't know what that means, because there is no agreed way to measure, report, and verify what countries say in terms of their carbon removal. So this has to be worked on. We also need to work on international cooperation to help finance and innovation, for innovation, development, implementation of these technologies in developing countries. And then, of course, and this is an interesting one, if we have the peaking scenario that Katharine mentioned, then we also need to think about reverse adaptation. How will people adapt to the dropping temperatures once we pass the peak? And this is not obvious by themselves. So I think the adaptation discussion needs to expand. And then, of course, and this is really key, we need a comprehensive risk management framework to manage the totality of the tools we have to manage climate risk, which includes mitigation, adaptation, carbon removal, also potentially other technologies that might be used, such as solar radiation management, and very importantly, linking all this to the implementation of the Sustainable Development Goals, which is yet another process, and the connections are not very strong for that. And then finally, and I will stop after that, we need mechanisms to understand better the transboundary impacts of these different technologies. And I'm sure there will be more discussion of that when we look at the technologies individually, but we need to understand better what those transboundary impacts are, and then how we deal with them, including possibly compensation methods that we might have to put in place to ensure that those who are negatively affected by some of these technologies can be considered. So I will stop here. As you can see, the overall assessment is that carbon removal is still at the beginning stages in the intergovernmental discussions, but it is there, and it is, the processes are in place. What we need is to push for a more substantial policy discussion and then eventual results of these discussions. Thank you.
Thanks. Thank you, Janos. I'm going to bring Wil in, and maybe I can bring you in by way of a couple of questions
Sure.
from those who are listening in, and also just your reflections on some of the things that Janos said. And so when I listen across Janos's presentation and what Katharine had to say, it almost feels like these technologies are becoming essential if we're to think about the carbon budget. And also through the way that the technologies were discussed, there almost feels like an inevitability to their development. And so one thing I want you to reflect on is whether you agree with that. That'd be a useful thing for us to hear. And then looking at some of the questions that are coming in, if these technologies are so important, why aren't they here yet? What's standing in the way of their development? And if there is support for these technologies, from what quarters is that support coming? I wonder if you can help us get a sense of some of that landscape.
Mm-hmm. Well, in terms of the second question first, I guess, in terms of barriers, there's a lot of barriers for these things to be introduced at large scale. First of all, as Katharine had suggested, we really have to do an assessment of whether large scale development of some of these technologies is sustainable. As she suggested, in terms of bioenergy and carbon capture and storage, which may be the most advanced of these ideas in terms of carbon dioxide removal options. At very large scale, you're talking about huge potential diversions of agricultural land that could have impacts in terms of food prices, large amounts of water, perhaps as much irrigable water as we use currently for large-scale production, and biodiversity impacts. And so it may be that we can utilize BECCS as part of a portfolio, but at a smaller scale, and we need assessments to be able to determine what those trade-offs are, what those risks are, and at what scale it's tenable. Another barrier to a lot of these technologies is cost. We don't have a social cost of carbon at this point that would drive the incentivizing of adoption of technologies that might cost somewhere between $100, maybe $150 per ton of carbon captured. Even in the European Union, for example, you're looking at a cost of carbon of around $10, less in the United States, less in California, and that means that to drive that, at least in the shorter term, you're probably going to need government mandates or some kind of capturing of externalities, and that's those are imposing. And then some of these other technologies are largely still based on laboratory assessments, small field experiments, and so we're going to need large-scale scale-up in terms of research and development just to assess viability.
Let me, do you want to step in there, Janos, or can I kick back to Katharine?
Well, if I could just address the one point that you raised, Simon, of why, first of all, why people are not really discussing it seriously. And there are a couple of reasons, in addition to the knowledge of many about these environmental impacts that Wil, you just mentioned. But I think it's important to refer to something that is called a moral hazard, where there is there's a possibility that simply even by talking and engaging in serious discussions about carbon removal, at least many people feel that there is that possibility, that there will be less energy and less political will to do what we really have to do, which is to reduce our emissions rapidly. Now, whether that is a real possibility or just a possible possibility or not, we don't have a lot of empirical evidence, but clearly we need to be cognizant of that carbon removal doesn't become an additional reason why we can continue to emit greenhouse gases. So that's a big issue there. There is, of course, another side to this, which is if we don't talk about these issues and if we don't recognize that we're actually in a rather difficult situation when it comes to overall emissions, the carbon budget, and so on. If we don't talk about it, then and if we have this false optimism that we'll solve this problem somehow, that is also a moral hazard, but going the other way. So we have to find the right balance between the two. And one more point about this issue is that some of us may remember going back to about more like 20 years ago now when we started talking seriously about adaptation to climate change. And there was a very strong view by a lot of people in the negotiation process, in the NGOs, oh, you cannot talk about adaptation because then we will stop doing what we have to do on mitigation. Same kind of thinking as we have today on carbon removal. And of course, we didn't do enough about mitigation, but I don't think it was because we started talking about adaptation. I think there were other reasons for that. So I think we need to look at these things and find ways to at least be able to talk and exchange views about these issues.
Hey, Katharine, can I turn back to you? I've got a couple of questions that have come in from those who are listening and viewing. And then I want to ask you a question or two about what you see as near-term research priorities. And so I'll let you kind of capture these questions as you wish. One question here is about the potential uses for captured CO2. If you can give us a sense of what might be done with CO2 that's pulled from the atmosphere. And then another question, which will probably lead into what you think about near-term research priorities. Under various scenarios that you can imagine, what is your best guess regarding which decade we may see or need to see the first at-scale deployment of CO2 removal technologies?
Great. So this question of what do you do with the CO2 once you've captured it straight from the atmosphere or off of electricity generation is a really good one. And I think one thing is you just store it. So it's not a practical use, you're just getting it into long-term geologic storage. There have been uses of CO2, and in some cases in the past, we've been drawing CO2 out of the ground for these types of uses, including enhanced oil recovery or use in greenhouses. And interestingly, some of the experience we've built to date in terms of industry side action in the carbon dioxide capture space has been more geared towards those uses, even though they are not really uses that are long-term and strategic in our climate responses. But the stuff of life is very much made of carbon, and there's been a lot of consideration of the degree to which CO2 could be used to manufacture many different types of products. We might move into a future where a lot of gases are more interconvertible with long-term storage into fuels, and this space of solar fuels, synthetic fuels are really interesting dimensions of especially strategizing on what the end game energy system might look like. And I think, Simon, you're exactly right that that second question in some ways really nicely ties together the research priorities that we've been working on over the past few years here at Stanford with a research team that spans from expertise on the biomass and land side all the way through to deep expertise on what it takes to get CO2 underground. And our philosophy really has been right around this concept that we've been calling right sizing, recognizing that assuming that we'll have 15 billion tons of CO2 removal per year through bioenergy and carbon capture and storage is a vast amount. So on the one hand, and I think this gets at the question of, well, what decade can we rely on these things starting to appear? For those really, really big numbers, what we've actually been doing is putting them into relatable units in the research we've been doing. So for example, getting towards the 15 billion ton deployments at the end of the century in model-based analyses of what that would take, actually over the next few decades, the expansion of use of the land for bioenergy is way faster than what we've achieved with major commodity crops historically. So for example, over 4 times the rate of expansion that we've seen for soybean, or over 19 times the rate of expansion that we've seen for oil palm. So on the one hand, right sizing, we've been starting from the top down, saying how big are these numbers? But then in some ways, the really fun part has been the reverse side of that, right sizing from the bottom up, really looking at the technical and also the economic potential for different types, especially of bioenergy with carbon capture and storage, and storing carbon into the land in the very near term. And I'll just give a few categories of research that we've been doing. So first of all, in terms of thinking about the near term, we've recognized that just on the engineering side, there are some types of responses that are likely to be harder to get out into reality, full-scale deployment, because of different barriers that come into play in societies and politics combined. Pipelines would be a classic type of infrastructure that's really cheap to model, harder to deploy in reality. So one set of right-sizing analyses that we've done, looking at the near-term potential for bioenergy with carbon capture and storage, giving you carbon removal by putting those pieces together, is an overlap analysis. Where could this technology be deployed globally in a way that you wouldn't need pipelines at all, could just go into action right now? In the US, it's about 44% of the counties across the nation as a whole, where you've got a basin right under where you could grow the biomass above ground, and that adds up to about 100 million tons of CO2 per year. If you extrapolate that globally, it's a little bit harder because there's less well-resolved data available at the global scale, but it adds up to about 1 billion tons. Going one step further and not just looking at technical potential, but really saying both technically and economically, what is the potential for bioenergy with CCS in the very near term? We've looked at the potential for capture off of bioethanol refineries, recognizing that that is a very strategic near-term entry point for building experience in this space, because you have a nearly pure stream of CO2 that comes out of ethanol fermentation. You can capture it, compress it, get it ready to send underground for $25 a ton, which is actually very affordable in this space. If you bring in the 45Q tax credits just revised, which are going to ramp up towards $50 a ton of sequestering carbon dioxide underground, this bioethanol refinery analysis gives you about 30 million tons that essentially are profitable now. That's really, really unique to be able to say in this carbon removal space that there are opportunities that are economically feasible, representing commercial opportunities now and in the very near term. And the last part that we've been doing is taking this near-term type of analysis and looking at options in the land space. So for example, California has a forest offset program, which is the first one in the world that is legally enforceable and applies to standing forests when it went into action in 2013 with 40 projects dating back to 2001. Again, it's on the small side of things. It's 5 million tons per year. But it's actually working quite well, and we can see many different risk metrics that are being deployed. At the same time, that there's kind of an interesting inversion of the conservation paradigm, where the landowners participating in this project are things like timber companies, investment companies, not necessarily people who would say, my job is all about conservation, but they're getting all sorts of conservation co-benefits from this use of the land to achieve carbon removal that then feeds into California's cap and trade system for industrial facilities overall. And really a compelling win-win type of situation, although it's still in the small near-term side of the overall spectrum.
Thank you. We've got a number of questions coming in which are asking about the downsides. And so one way to kind of think about the conversation so far is, look, we need this stuff. We, humanity, have dug ourselves into a hole, and now our options are limited. If we don't develop these technologies, then we might be sunk. I mean, that's one kind of blunt way to characterize what we're hearing so far. Some of the questions coming through basically are of the flavor, can we count on these technologies? And if we do start to count on these technologies, are there risks that we just aren't kind of ready for? So I'm seeing some questions here about bioenergy with carbon capture and storage and what it might mean, say, for food competition. Maybe we can flesh out some of those potential downsides and risks as you started to do for us, Wil. I see some questions here about storage. So, you know, we want to take this carbon and store it underground. How certain can we be that carbon that gets stored underground will actually stay there? So maybe between the three of you, you can help us kind of think about the downsides and how we, you know, do the kind of risk management type assessment, Janos, that you were suggesting is needed across the full portfolio of response options. Wil, do you want to start with that?
Yeah. Well, I think if we focus on bioenergy, there's definitely questions associated with diversion of agricultural areas for dedicated energy crops, which could result in serious increases in food prices, or it might require us to clear other lands for more agricultural production, which in turn could result in releases of carbon. And so we need to realistically look at those options. There's also research in bioenergy for second and third generation feedstocks, looking at things like utilizing other parts of agricultural crops, for example, that wouldn't require us to be diverting these resources in terms of food. There's third generation research going on to utilize things such as algae, which could substantially reduce the potential footprints in terms of food. But all of these have some serious questions in terms of scale, cost, and potential environmental impacts in themselves.
I'd love to take on this question of risk and then maybe go to Janos. I think the question comes up a lot everywhere in the space of climate responses. How do we manage the risks, not just from climate change, but also in terms of responding to those risks, recognizing the risks of responses range from policy risks. We often don't know exactly how effective different policies will be when they go into play. There are risks for the changes and uncertainties, the disruption of economic shifts through time. You talk to people in the business space and they say, oh, those risks of disruption are all about opportunity for building new industry, at the same time that you really have to manage who is losing versus winning. And so I think if we just kind of were to be really hyperbolic in some ways, you could say that any energy technology has risks. We certainly understand that from our fossil fuel-based energy system right now, where it has had unbelievable benefits for humanity. Countries that are wealthy right now have a high quality of life and well-being of their citizens. They got there on the basis of fossil fuel emissions. At the same time that there is no response that is perfect. We do not have a miracle cure. We're looking at replacing through the century our current energy infrastructure, building energy infrastructure in places where it doesn't yet represent a major basis of the economy, and doing that with technologies that exist right now, things that will come onto line, and there is no easy cure. So we could, for example, go through all of this space of responses, and if it's wind, of course, there are questions about siting of that. There are questions about birds. If it's solar, again, there are questions about siting. For both of those, the questions around risks of variable generation are real. For nuclear, same thing. Hydro, same thing. Storage, same thing. Carbon removal, same thing. So in many ways, just because there are risks of technologies, it doesn't really mean that you want to set them aside. If we set aside everything that is risky, we would have no way to solve this challenge. Instead, we need to be managing those risks from responses. And the types of risks are exactly the things that were unfolded in some of those questions, the questions around land competition and the responses that Wil described. I would just point out that the question about the risks of storage are actually quite different. So if you are storing carbon in the land, for example, in a forest, there is real reversal risk that is possible. In terms of getting carbon into the land, it tends to be slow in, fast out. When a fire happens, for example, that is in many ways the big risk there. And that risk of loss of carbon on the landscape goes up a lot in terms of scenarios of high amounts of warming. In terms of the risk of loss, once you get carbon dioxide deep underground, it's actually quite a lot lower. It tends to diffuse into these rocks and actually become less likely to come back up. We've really worked intensively with leading experts in the carbon capture and storage space to really get at that with maximum nuance. And they would really emphasize that the major risks there are really not about leakage, especially over human life scales.
Katharine, thank you. Janos.
Yes, just actually going very much from where Katharine stopped. So we have all these different risks, and there is nothing that is risk-free. We don't have that option. And the question is, how do we bring this together? So I just want to offer three particular sort of ways to proceed. One is that, first of all, we need to better understand from a systems analysis perspective what actually those risks are and how they impact different parts of the social, economic, environmental system, because it's the totality, and we need to at least understand what those are. The countries of the world have just agreed a few years ago on these, in my view, pretty fantastic sustainable development goals of what kind of a world we want to live in. So we have some picture of what we would like to achieve, and we know that each one of these technologies will have very substantial impacts on those goals. Not always negative, sometimes positive, but we need to understand what they are and what how those interactions happen. So the first is analysis, assessment, understanding. There's a lot of research there. That's the baseline. Then secondly, we need institutions that talk to each other, because we have very different institutions globally and at the domestic level as well, who address these different topics in a completely different way. Even within institutions, sometimes you have groups that are dealing with the forest and somebody else is dealing with the water, and they don't talk to each other. So we need different parts of the constituencies to talk to each other based on this kind of systemic assessments that we will have done, so that we can actually come up with approaches and policies that, instead of solving one problem and creating 5 others, they may actually solve 2 or 3 problems together and not create other problems. And thirdly, and this is very important, because sometimes the risks, these different risks, can be very differently perceived and internalized by very different people because of their cultural, geographical, scientific backgrounds and so on. So we need really serious society-wide discussions about these technologies and the different risks, so that there can be a better acceptance and understanding of these different risks across different geographic boundaries. So those 3 things might help.
Thanks. In addition to the 3 things you spoke about, Janos, we had some near-term research priorities from Katharine around this idea of right-sizing. Well, I wonder if you want to add a couple of near-term priorities from your perspective.
Yeah, I'd add a couple. I think Janos had mentioned that potentially the parties to the Paris Agreement might take up carbon dioxide removal options in the future as part of their pledges to mitigate under the nationally determined contributions. If they're going to consider doing that, we're going to need protocols that address some of the critical questions about whether countries can claim that as part of the way that they're meeting the temperature targets. That could include, in the case of some of these technologies, such as bioenergy and carbon capture, the issue of permanence. How long will this carbon be stored? Also, the issues of direct and indirect land use changes, which obviously could result in additional releases of carbon or additional storage of carbon. And questions that Paris has about impacts of these technologies in terms of biodiversity or potential impacts on human rights. A number of them, as we've indicated, may have risks, and those need to be compared with risks of other options. And then at the national level, I think we need to start assessing what national laws and regulations might be applicable in terms of research and development of these technologies, and then potential deployment of these technologies, and whether we'll need additional laws or regulations to help us in assessing these technologies and potentially utilizing those technologies, and then figuring out how to coordinate national and international regulations.
So we have a few minutes left for some rapid fire questions. So I'll ask you to keep your responses to these questions relatively tight. If we can turn back to you, Katharine, quickly. There are some questions here about, let's see, what alternatives do you see for negative emissions in the transport sector besides the capture and storage of CO2 from bioethanol plants?
That's a hard one. You know, in some ways, we have a paper that will likely be coming out in Science in the next few weeks that has been looking at hardest to decarbonize sectors of the economy and how you might grapple with them.
Yep.
And a big part of the hardest to decarbonize is indeed long distance shipping and airline transport. That is a place where dense fuels like biofuels or synthetic hydrocarbons might be really important moving forward, although they're so hard to decarbonize in some ways that you would be thinking about, can we get them to zero? Not necessarily are those the main places where we'd want to get net negative, at the same time that they can be part of this broader landscape with carbon removal overall.
Great, and a question here about bio-based plastics used as packaging. Is that a scalable technology? Do you have any sense of that, Katharine?
There is a nice paper that came out that really emphasized that for a lot of these utilization features, they're relevant, but we certainly don't want to be thinking billions and billions of tons. That's the sort of thing that if we got that to 1 billion tons, that would be really big.
1 billion tons of what? Can you just give us a sense of, one thing we haven't really talked about is, except in passing, is the scale at which it's imagined these technologies might be used. So can you just give us a sense, when you talk about 1 billion tons, help us understand that?
Great. Okay, so current global emissions, if you count everything, are over 40 billion tons of CO2. You count other greenhouse forcers, you're kind of up to 50 billion tons CO2 equivalent. The world's largest emitters are China and the US, and they together add up to about 15 billion tons of CO2 emissions per year from industrial and fossil fuel sectors. So when numbers get thrown around in the space of climate responses, the number of zeros on them becomes really, really important, because, you know, when I talked about California's forest offset program as being wonderful at 5 million tons, that is super different in terms of overall scale and scope as compared to discussed deployments of, for example, 12 billion tons of CO2 removal through planting forests.
Yeah. Okay, thank you. Janos, a couple of questions here about, first, the role for civil society in assessing carbon dioxide removal. It would be great if you have some thoughts on that. And then a second question is about country contributions and what it's realistic and reasonable to expect from different countries when it comes to carbon dioxide removal. I'm sure there's an equity dimension to your answer there as well.
Yeah, so for civil society organizations, I think the number one and the most important role they have is to hold governments, national, local authorities accountable to what they have said that they would do, and to make sure that they end up doing them. And the civil society organizations are very good at that, or they can be very good at that. But at the same time, there are also many civil society organizations that are able to engage with different actors and actually come up with interesting new solutions. And we've seen that in the past. Just think of labels like for fishing products and for forest products. So those are all NGO-initiated activities that engage the private sector and governments, and they ended up working very well. So I think civil society organizations also can contribute to really interesting ideas on how to move forward. Now, when it comes to country contributions, this is a big issue that I think hasn't been addressed in the sort of the intergovernmental space. I was once in a major emerging country not so long ago and asked about their plans for carbon removal, and the person said, "Oh, that's not for us, that's for the developed countries." So you know, that fundamental discussion it's been a very difficult discussion on the emissions sector. It's been going on for years, and I don't think we had a really sufficiently good and equitable outcome, but still there is some understanding that the developed countries have to go first and everybody has some responsibility. But we haven't had that discussion at the level of carbon removal. Is it just simply a simple equation relating to your historical emissions? Maybe. But this needs to be discussed. So it's very hard to say what should be the contribution of countries. But if you simply do it in an equitable way, it should be possible to look at historical emissions of countries and compare and sort of calculate what is the fair share of each country based on the carbon budget that we have. And if we have to remove, let's say, 10 billion of those 10 billion tons of emissions annually, let's just say, then it would be possible to calculate what is the share of the historical responsibility for China, for the United States, for a state like California, or even for a city. Why not? So it should be possible to do that. But at the moment, we have not done that, and we haven't had any kind of intergovernmental or inter-actor discussions of this, and this is something that needs to happen. But in the meantime, I'm aware of some countries where NGOs, for example, are already pushing their countries or their local authorities to say, if you need to start thinking about carbon removal, and this could be our responsible carbon removal level that we should aim for. Mm-hmm. So there is already this kind of things happening in some countries.
Yeah, and yeah, from the perspective of the forum and my personal perspective, the conversation is so fragmented at the moment. in the intergovernmental arena, but also between different civil society actors and so forth. We don't have good assessment frameworks. We don't have good risk assessment frameworks. And at the moment, we have a conversation where we can't even agree on what carbon dioxide removal is as a thing that we should be investigating. It's much easier to speak about the biological pathways that Katharine mentioned earlier, planting trees, taking carbon into the soil, because those are familiar things to many of us who have been concerned about climate change for a long time. It's much harder to talk about these more technological or mechanical pathways because they can seem a little science fiction and far off. And so at the moment, we're not having a reasoned and reasonable conversation, it seems, across the entire universe of technological options. And this relates actually to one of the final questions that I'll ask you. There was a question here about whether carbon dioxide removal should be considered geoengineering or should it be considered mitigation? And that seems like an academic question in some senses, that we academics love to play with these categories, but it turns out it's a really important policy question at the moment. Yeah, if we consider carbon dioxide removal mitigation, then it's a more palatable thing to talk about in the international climate response context. Whereas if we consider these technologies geoengineering, that has a whole set of connotations that make it a little bit scary and off limits. So I wonder, Katharine, if you want to respond to that question first, and then I'll kick to Janos. We have just a couple of minutes left.
Great. I think in many ways, the discussion for a long time on geoengineering has pushed towards nuance, recognizing that the types of risks that are relevant differ a whole lot, whether you're talking about trees on one side of the geoengineering spectrum, all the way through to putting sulfate particles into the stratosphere. So I think nuance is necessary at the same time that, as all of you have been discussing, as this comes into the policy sphere, it takes on a whole new level of importance of getting the definitions straight. I think what's been really interesting watching the state of California, for example, over the last 2 years, really trying to bring land into its climate policy landscape much more ambitiously. And I think there's been a real recognition that even when you're talking about land, if you're putting that in a direct one-for-one comparison with reduction of emissions from industrial facilities or transport, that you still want to be attentive of the fact that the risks are different. For example, it can be very hard to measure exactly how much carbon is going into soil in terms of a project-by-project type of evaluation. Or if you get more carbon in the forest, as we talked about earlier, that can be lost very rapidly if a big wildfire happens. So nuance is necessary at the same time that recognizing even in the carbon removal space, the technologies look different. It's helpful to think about 2 or 3 buckets relevant there in terms of the nature of the risks. And certainly when you go into the solar radiation management space, there are a whole other set of questions that come into play, recognizing that we really don't, as you all have described, have governance systems in place for those types of risks.
So Janos, complex question in 1 minute.
Yeah, okay, so I think starting, we need to be clear about why we're using certain expressions. We've asked some of our friends and colleagues working in this area, and they each came back with very different reasoning of why they're using certain words and phrases. I think one of the problems is the word mitigation, which we use as an equivalent for emission reductions, but in fact the English word mitigation, it doesn't mean emission reductions. So we have already the problem with a word that we're widely using for something that in fact was meant for something else. But ultimately, I think what is important is that there be clarity in the different institutional discussions that take place, that people, when they say something, they mean the same thing. So if you say carbon removal is part of mitigation, which some people are suggesting it should be the case, then that be very clear in that particular process that is what is meant, so that there be no confusion. And there will always be different groups for different reasons, political, economic, scientific, that they want to use a different terminology within their own context. But when we come together in international or even at the national level, we need to be clear about how we call these things. At the end, what you call them is less important, to have clarity that there be agreements of what we mean by each of those phrases and words.
I wish we had more time, but we've come to the end of our allotted time now. So let me just thank you all. Janos Pasztor from the Carnegie Council Geoengineering Governance Initiative, C2G2, Katharine Mach from Stanford University, my colleague Wil Burns here at the Forum for Climate Engineering Assessment. This has been the first in a series of webinars on carbon dioxide removal technologies that the Forum will be organizing and running over coming months. The next two that we have lined up will be on soils pathways and on bioenergy with carbon capture and storage. So stay tuned for announcements about these upcoming webinars. All of the webinars will be archived on our website along with supplementary materials. The website for the forum is ceassessment.org. Okay, thank you all. Thanks for your time. Look forward to seeing everybody next time.
Thank you. Bye-bye.